We're excited to be here at the week 3 Fireside. We have Acacia with us, and we're actually treating it a bit more like a Junto, which Acacia, you may remember as our Wednesday exercises in the afternoons, usually. But we've uh, made one out of every 2 Thursdays a bit more Junto-y during fireside time. And what that means for everyone is we'd love to hear from your voices, although we'll get started with a bit of back and forth on um, Web3 and like what it is and what it has been uh, defined as, and also what uh, in what ways we've fallen short of the ideal. Um, and then we can branch out into further dialogue. Um, First, I have shared in the chat the signups for Expo. Encourage, especially if you have kind of like a project or prototype or a work in progress that you want to share. The 2 days are October 28th, 12 days from now, and then October 29th, 13 days from now. So sign up now. It gives you a chance to get yourself going. And it gives us a chance to reach out to you and start getting feedback together in advance of Expo, but in practice also just to keep things moving well for for your project and for the energy that's being put into it. I think that as we get into this phase of kernel, it's uh, an attempt to look at prototypes, to share those prototypes with the people that they're going to matter the most to, and for us to be a part of that process of encouragement is really our top priority. So we want to see your works in progress, and that's ultimately what Expo is about. We'll have a bunch of smaller rooms where you'll meet, call it 2 to 3 people who are interested in your work, with uh, a framework for them to stay in touch after and be included on any updates that you have well beyond Expo. Um, Office hours continues on the way, so please consider signing up for next week if you haven't presented recently, or even if you have and you just want to keep it rolling, it's open to you any week. So I'll leave the office hours sign up as well in the chat. And we'll get into it. I I want to start by introducing Acacia briefly. She was with us in KBX, and the way that I think about it is pretty much, I feel this way about a lot of people on this call, which is that, you're maybe earlier in making your name fully known in whether it's the crypto space or um, in the technology space, but I think everyone here um, has a chance to make their mark in different ways, and I've really felt that way with Acacia since we met. She comes from a background uh, in computer science. She was one of the youngest managers at American Express, worked a bit on their blockchain work amongst other things, and joined Kernel with a focus on concordance, which was and still is a project that's really tied to this module on taking back the web and Web3. And uh, the term has meant different things in different eras. I think it's kind of like less interesting to talk about Web3 itself and more interesting to talk about the ideal of like what that type of technology stack would enable. And Acacia, through her work on concordance last block and continued work on it into this block, has helped us to achieve a greater understanding of it. And so I want to welcome Acacia, and if you'd like, you could share a few words on kind of like whatever it is that you'd like. related to that, and I can also add some more color from the module.
Awesome. Thanks for the intro, Vivek. Yeah, I actually put together a few slides, mostly from my presentation last year on the same thing. And I hope to use them more to sort of guide the conversation than to give a formal presentation. But I've kind of broken down what the web is, who owns it, how it's owned, what it means to rebuild it. I think that all kind of comes to a conclusion on the active research I'm doing with intense and programmable transactions and what this new web looks like and how we can build applications. So yeah, I'm super excited to chat and hopefully have a lot of great feedback from everybody in attendance.
That sounds great. That sounds great. Maybe we just get into it if you don't mind, Acacia. I can get into some of the other parts of the module. Well, you know what? There is one slide at least I can share.
Yeah.
The the module the module starts with some prehistory, and really is trying to look back at what the web um, was intended to be by its initial creators, and tries to look critically at like, well, why didn't we get there? And so it takes reference from Brewster Kahle, who was one of the early internet pioneers who in 2015 wrote a post called Locking the Web Open, a call for the decentralized web. Um, and a 2018 talk by Juan Benet, who um, was one of the original co-authors of IPFS, which later also led to Filecoin and distributed file storage, and um, has this really great talk on what Web3 could be. And both of them also reference back to Tim Berners-Lee, um, who kind of has always also had an idea for a Web3. But that Web3 was coined in 2004. Um, and it was called the semantic web, where, um, to briefly describe it, it says from the 2004 version, it says many websites contain unstructured and textual data. Web 2 is few large websites are specialized on specific content types. You can see Flickr and YouTube and encyclopedia articles. And then the other and last one was many websites containing and semantically syndicating arbitrarily structured content. And so that's an interesting one because some of those terminologies we kind of like have moved away from as we've moved into our new definitions of Web3. And so this is to illustrate the one of the mechanisms of the web and of this like narrative of taking back the web. There are three pillars that we talk about. So this like semantic web, linked data, Web3. I think that one we've tied to extending our ability to cooperate. The other two pillars we've explored in this module, which may be for a later date, but are worth considering, are the web at its best can augment our ability to think, and augment our ability to think for ourselves. The bicycle for the mind was one of the early analogies, but in what ways has that been co-opted is kind of like a pretty obvious line of questioning to ask. And oftentimes our attention is captured, which also relates to our time. So when we think about a better web with better incentives, is it a worthwhile ideal, and is it a realistic attempt to be making to reclaim our time from this web of ours? I'm not sure that we'll get into all of that immediately, but perhaps that can get get into discussion after we look at Acacia's slightly more technical look at what the web is, because I think that's really the best place to start.
I'll share a few slides I've thrown together. Okay, so I think the web is this kind of nebulous sort of thing. Most people are hardly ever interacting directly with the web. They're interacting with applications, which oh, I don't know if I've okay. They're interacting with applications which take the concepts of the web and apply them. That's why they're called applications, right? They're applications of a certain type of software. They're applications of a process. They apply these concepts of the web, but most people interact with some sort of interface that sort of abstracts the web, whether it's an operating system, your cell phone, or a web browser. Underneath all of that is actually a suite of protocols and conceptual models that actually allow the internet to operate. All of these things cooperate with each other. They're well established. This is the web, and all of that is predicated on this fundamental assumption. So when you look at the top layers of the protocols that enable the web, they all go off a fundamental assumption of a client server architecture. The reality is any machine that you have, whether it's your laptop or your phone, any machine has, it's just a machine. It has the ability to run software that allows you to be like, you download a browser and you're a client, or you download some server software and you're a server. So every machine has the ability to play either one of these roles, but we assume that these two roles exist, that there's a client and then there's someone being served. The client is the one being served. And what businesses have done with this sort of architecture is they've said, okay, well, we can offer a service. Like if I'm a bank, I can offer banking services. If I'm a shop, I can offer commerce services digitally. Social media is a service that you're provided, but the server sits and services you as the client. And that seems good and well. You can receive information, but what it's sort of created is a growing amount of control over your autonomy, your data, and like Vivek was saying, your time. And you just sit there and you're almost like, it's like a parentification sort of relationship that's come over time and taken this client server into almost like a nefarious sort of architecture. Um, and the only recourse you have is legal recourse. So the assumption of trust here is that you, as the client, are interacting with this big service provider, and that service provider is going to operate nicely. They're going to be responsible because they could face legal ramifications. I used to work in finance, and we did a lot regarding like FCRA and Dodd-Frank, because around 2008, we found out that service providers, banking institutions don't actually care about the best interest of the client, right? They just care about how they can kind of increase their own personal sales. And so you have legal acts that come as a response to that. And you just have to like sort of hope that the service provider is acting in accordance with the laws. And what I mean by that is like I used to work in banking, right? FCRA and Dodd-Frank are focused on credit. So there actually are not legal stipulations on how a bank should manage your banking data. The bank just makes it up. And what happens is they get audited, typically by a big four company. So think of like the big four consultants. And as long as you pass the audit, then you're okay with the government. there's no real processes in place. There's some basic things, but like my day-to-day job when I was working in finance was basically taking our consumers' data, right? It's you as a client, you send your data to the server, and we took all that data and we sent it to third parties. So your data is owned by the bank, and so the bank can do whatever they want. And as long as they're not breaking any certain laws, meaning as long as they pass the audits, then they can continue to do that. And so you have a $400 billion data aggregator industry that's reselling your data, it's moving your data around, but it's also decisioning on you. So if the third party service deems that you're too risky, then they can report that back to the institution, and the institution can remove your right to banking. And this is just an example of how this seemingly like innocent client server architecture is kind of grown out of control and stripped you of some of your autonomy and ability to make choices. This is also how like debanking happens when an individual gets blacklisted at one bank and then all of a sudden they can't bank anywhere. It's because those banks are sharing data in between each other and making money off of it in the process. Um, and so when I think about taking back the web, I think about just reinstating my personal autonomy, electing into participation because I have transparency on the processes. I don't want to be censored. I want my same, I'm an American and I want all of my rights, or the freedom of speech and freedom of all of these things. I want all of those things to still be in effect in a digital capacity. And I also want the ability to selectively disclose. I don't want to give my information to a bank and then have that bank take my information and give to someone else. I want the reclamation over how that happens online. So I just want a balance of the scale, right? Taking back the web to me doesn't actually mean um, like I don't know, like living off the grid. It just means taking my personal agency back and acting in accordance with my personal agency. And so for me, how I take back the web is the building, operating, and participation in a web that is a viable alternative to this web and this web. Uh, so I want the ability to opt out of a web that doesn't serve me. And right now, we only really have one version of the internet, one version of the web. You can't fully opt out of it, even when it comes to something like service providers, right? You fundamentally, at any level of a digital interaction, you have service providers, meaning your physical computer, your phone has etched into the physical hardware stipulations that allow people to control your interaction online. Your MAC address is the lesser known address for your IP address. And those things basically map together, and internet service providers facilitate that process. That's why you have to pay for Wi-Fi. That's why you have to pay for, uh, back in the day, you had to pay to like send longer range messages, that sort of thing, because people actually own that lower level system and infrastructure. So when we talk about taking back the web, we have to think about the full stack of the web. And we've started, I think, in the blockchain space and in the Web3 space to really investigate what that means by the foundation of something called like trustless compute, which doesn't actually remove trust assumptions, but it enables, again, this like individual autonomy where you have transparency to verify the behavior of a third party and facilitator. So I really like the language that we use in kernel with trust verifiable compute, because I think that's a more accurate representation. You're trusting that these people are going to do the right thing because you're able to transparently see what's going on. You're able to verify those sort of interactions. So we're moving towards this new sort of web. But I think the fundamental ability to enable this is just a hard problem. When you don't have a centralized entity, when you don't have centralized actors, and you want to be able to do compute in the face of Byzantine or basically malicious actors, you have to start, like when you have a huge problem, you kind of start by whittling it down, right? And so we've whittled this trustless internet or trust verifiable internet down to a subset of problems, and a subset of cases where we opt into trust. And what I mean by that is in the blockchain world, blockchains are what computer scientists call finite deterministic state automata. So there is a finite, meaning measurable, capped amount of state, which we represent as tokens, and they're deterministic, meaning that there is no unexpected behavior that we expect to happen. So how we whittle that down in implementation is we say, okay, this blockchain has tokens. They have native tokens which make up their state. And those tokens can be transferred. That is the totality of what blockchains do. They just transfer tokens. Now, smart contracts kind of allow us to add additional logic that comes before, precedes the actual transaction or the state transition, the changing of who owns the token. But fundamentally, blockchains are just exchanging tokens between different owners. So when you think about what a liquidity pool is, all it is an individual giving the ownership of a token to a smart contract that balances liquidity for them. So you can precede token changes, and you can, after the token change, you can also do some computation, which is what liquidity pools do. Every step of the way, you're able to verify the sort of computation that's happening. And you also can verify that you have the ability to reclaim your token once the liquidity pool maybe has leveled out. And all the so how liquidity pool works is you have, like, and I don't mean to digress here, but you have two tokens, and the tokens are exchanged, and when a token is exchanged, a slight fee is taken, and you get to reap the benefit of the fee that's taken as those tokens are exchanged. And so what you have is a promise, you have a receipt that says I can go and get those tokens back maybe whenever all the tokens I put in are exchanged 3 times or whatever. You can set your own rules and go and get that token back. But you can elect to opt in to that sort of computational interaction. Those are the types of things that we can do in Web3 that are actually fully decentralized and fully trust verifiable. There's many things that we do in Web3 where we sort of compromise on the actual decentralization of the process because we get the verifiability of the system. Meaning, you might choose to um, swap with a centralized exchange because of the convenience of having a centralized exchange, even though they are centralized, right? But they're you can verify some of the properties of the interaction on chain. Not all of them, right? So there's some opacity when you elect to centralize. Decentralization and trust verifiability are sort of things that go hand in hand. So how does that happen? Like, what's actually happening at the web layer that's enabling these sorts of things? And we can look back to like early instances of computing where we had like researchers who were using the internet to just sort of exchange files. That was a network of connected computers, right? But it wasn't the internet, the interconnected network that we have today. The same thing is true for blockchain. Like, we have this network of trusted nodes that participate in peer-to-peer connection. They participate in gossip. They can intake requests, and they share a mempool. They share a network of state, but they're not an interconnected network. So I think blockchain gets us part of the way, but hopefully it's kind of clear that we're not fully there yet. Um, a lot of the active research that I'm doing and I'm working with some really smart people on is the enablement of what we believe is a closer version of a new web, a true web 3. So just looking at like the topmost layer of our current web, you have something like HTTP, which is one type of protocol that allows you to send a message, any arbitrary message, through this internet. You can put whatever you want. The sender may reject it. The request may be invalid, right? You may not have the right authorization, but the HTTP protocol itself makes no constraints or stipulations on what kind of message you can send. It just allows you to send a message through the network. TCP, IP, there's different parts of the network that allow you to route that message, so on and so forth. Um, how do you do that on a decentralized internet, though? How do you maintain selective disclosure? How do you maintain individual autonomy, consensus? How do you do that in the face of Byzantine actors? Um, there's just so many things, right? And so the active part of research, and I don't know if you guys have heard of intents, but intents are this also super abstract concept, as is the web. But the idea of intents, at least in my mind, is you have this type of message, you have this type of, like, it's like a box, right? Just like an HTTP request is a box. An intent is a box that allows you to send any type of message through the web, this Web3 web. And so you now have something that goes just beyond a network of interconnected nodes, like meaning the Ethereum blockchain or the Bitcoin blockchain, but you actually have a box that can package anything to any of these respective systems and do any sort of request. Now, again, just like HTTP, you can send a request and that end user can be like, no, this is an invalid request. We throw a 404 error, but you can still send that request. So that is what intents are in my technical engineering definition, right? Um, and in order to actually enable that, you have to rethink your entire web model. So the blockchain model is okay, it was insufficient, mostly because it relied on some Web 2 standards, it was missing some layers, and it only was restricted to its own network. The idea of this new web that I'm excited about, I'm working with a team that's building the Anoma project, and they have thought about every single layer of the internet. And what allows us to actually send an HTTP request through the internet, have that request received and responded to, they're creating that same model and using intents as the mechanism to send requests through the system, receive responses, maintain selective disclosure, adhere to consensus in different sort of networks that have different consensus models. State that maybe you have some state that lives on Bitcoin and you have some state that lives on Ethereum. You can send these requests, although state is fragmented. It gives you a vehicle, a centralized vehicle to do that sort of interaction. And that, to me, a developer, as an engineer, someone who builds in this space, is incredibly exciting. So
Yeah.
I'm taking that arm of research of intents and I'm whittling it down to a small subset of what I call programmable transactions, which is really more so enablement for a developer to be able to take this application stack and leverage it for their individual use cases. So even developers, when you look at this sort of structure, they're very rarely just writing HTTP requests, right? Typically, they have some sort of primitive, like a server primitive, or they have some framework. If you guys have heard of things like Node.js, if you've heard of React, those sorts of things offer a clean layer for developers to write code that they know is going to run on HTTP. So the research I'm conducting is effectively the same. I'm creating this kind of resting point and protocols so that developers can write code that they know is going to run via an intent, and they also have certain guarantees, right? When I send an HTTP request, I'm not just sending it for fun. I'm sending it because I want some information and I want certain affordances, or it's not even necessarily guarantees, but just the knowledge that, like, when I send HTTP get this post from this person, I know that that post exists. I know it's going to come back. We want to provide that same affordance to developers where they can send a request into this decentralized network. They know that the data is there, they know it's going to come back, and they have the ability to kind of traverse through this entire system and get their request back. And you
Keisha,
Mhm.
this is fantastic. Can I ask one clarifying question? You may already be getting there, but just to make sure, because it's a good amount to understand. I mean, I didn't really even rock how far down the stack Anoma was going with the research. And when I when I'm trying to conceptualize, the question I have is just like wh- what 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 are some examples of net new requests that can be made now? And we know from earlier in, as you're speaking, we know Web3 is about selective disclosure. It's about a bit more of a peer-to-peer foundation for the web instead of a client server. We know it's about trustless, or as close as you get to trust verifiable, really, compute. So we have some maybe assumptions that these new types of requests might be related to those things. But could you maybe paint some pictures of like, okay, well, I'm making an HTTP request to go to some website. That's my day to day. I do it 500 times on my computer. But what
Right.
is an example of a programmable transaction that I have never had the capacity to do before that now maybe I should start to imagine that I could do?
Yeah, I think there's some maybe obvious ones, and then there's some non-obvious ones. So I'll give you an example of both. The obvious one is today I have, let's say, I have 5 Popcat on Solana, and I am done with Popcat. I want USDC, and I want to be able to exchange my Popcat for USDC. Well, today I have to go to an exchange and I have to say, okay, like, you own some USDC. Can I trade my USDC for Popcat? And they say, sure, fine, whatever. And unfortunately, exchanges sit on chains. So I have to go to the Solana exchange and say, can you give me Popcat? Can you give me USDC for my Popcat? And it has to say, oh, actually, we don't have USDC. We have wrapped USDC. So we'll give you some wrapped USDC, and then you can take that to a bridge, and then the bridge will take it and it'll exchange your wrapped USDC for real USDC that's actually sitting on, I think it sits on Arbitrum or Optimism, wherever Circle is. And so they say, yeah, you go and figure out that over there, and that's kind of the exchange that you have today. The future with this sort of architecture is a promise where you can say, hey, I have USD, I have Popcat, and I want USDC. I don't care what chain Popcat is on. I don't care what chain USDC is on. And I don't necessarily need it from an exchange. I just have this thing that I want, and I want to make a request to get this other thing. So it's like HTTP, get this thing. And when you get this thing, you take this thing. Like that is it's a two-prong, two-layer request. And in HTTP, you can send these like two-layer requests. You can say, get and fetch and whatever. And the idea is that you can make that same sort of request through this system in a direct interface. So I, as a developer, can allow you to pay in whatever token you want, even if I want USDC. If I have a wallet and I say I only want USDC to my wallet, I can allow a user to pay however they want to through this sort of new web. So that's like the simple use case. I think a more interesting and more complex use case is like, let's say I'm just looking, like I'm starting like a pickleball club and I want local people in my area to play pickleball with me. um
Mhm.
what I need is I need counterparty discovery. So in that first example, you can see how counterparty discovery is kind of baked into that. And actually, let me extrapolate on that first example. What's happening when I say I want USDC is I am looking for a counterparty that has USDC and is willing to take PopCat. So there is some counterparty discovery that needs to happen. It's not sitting in some liquidity pool, it's somewhere in the network. And I can find where it is in the network, typically because that person has already made a request themselves. And I can match those two requests and say, this person wants USDC for the PopCat. This person is okay with taking whatever for their USDC, or they want PopCat. And we can fulfill those requests together. So actually that example is, it has some counterparty discovery aspects to it. It has some state separation aspects to it. Hopefully that was like fully representative.
Yeah. And you wanted to, and I know John raised his hand, but you wanted to elaborate on that to then help us with this pickleball example. Is that right? Because the counterparty discovery component could be relevant in the slightly more advanced. And then after that, maybe we get back to John's question.
Yeah, yeah. So I was using the example of the pickleball club because I think that's a good example of selective disclosure. If I am a person who just says, hey, I want to meet new people in my area, and a request comes through that looks like, hey, this person is in your area. Do you want to disclose to them information related to who you are and where you live and what your interests are? You can opt into, and you have basically more individual autonomy to decide, yes, actually, I want to give this person, you're not giving them your like literal MAC address of your physical hardware, but you're giving them a sort of piece of your identity. And you can also, because a gnome has gone all the way down the stack, you can select which aspects of your identity you want to disclose, right? Maybe I just want to disclose that I live in Northern California. Don't want to give them the city, but I want to selectively disclose this information. And maybe that allows me to continuously disclose new information over time. But those sort of capabilities are now inherently available to people building apps, interacting with apps, and just interacting on this new web.
Amazing. John, did you have something?
I do, yeah. I'm
Hey.
hey Akasha. I'm a bit winded. I'm like halfway up Parliament Hill, but yeah, I really appreciate um the conversation. I think it's been bringing up a lot of things, but I've been thinking about I've been trying to make sense of intents myself over the last little while, and um just doing some kind of pattern recognition, and also seeing how it relates to the work that I'm doing and what I can learn from what kind of seems like a really common pattern in computing, which is this process of kind of increasing sophistication by through abstraction, like by standardizing and kind of creating these standardized abstractions of more complex components, we can build more and more advanced things by boxing up a lot of the complexity in these like much simpler interfaces. And I don't really know if I'm saying this very well, but yeah, I just wrote a post about this actually that I have been sitting on. Every generation of tools hides mechanical complexity behind a simpler interface, and each step up that abstraction ladder allows creators to express intent rather than procedure. And I say intent here not just in the context of intents, although I think that is relevant here, but also an example I've been thinking about a lot is kind of containerization in Docker, right? Like I remember when to run a virtual machine, I had to install parallels and like it was a whole thing. And when I learned Docker, I was just flabbergasted that I could write a few lines in a YAML file and I could set up a Linux machine running on my computer just like that, right? With intents, it's a similar thing. It's I gotta like figure out a wallet for this chain and get gas and go get an exchange account. No. But if we create this higher level abstracted container or way of asking for what you want that can be interpreted by the system, then that complexity can be kind of handled under the hood. So I guess I have a question about this, which is, what are some of the trade-offs maybe that we see in going through this process of abstraction to simplify the experience, both in terms of the benefits we get from it, which seem quite clear to me, like a lot less work, maybe a lot more expressive power, like Kubernetes as an example, but also what are some of the drawbacks or things we should guard against as we're designing those higher and higher layers of abstraction that we still want to, like, I guess, not necessarily close down pathways to what's possible by committing to the constraints that you have to commit to in order to create those types of things. I realize those comments in themselves are quite abstract, so
No, I think they're great. I think they kind of point to a very valid, like basically what you're saying is like, how do we not repeat history, right? Like when we started off with the internet, like it was like benevolent, right? Like everyone was interacting and life was good. And then all of a sudden it became this bad thing. And so we have to be careful that we don't do the same thing with intents. I think that's super valid. But I also think that is the crux of why Anoma is gone so far down the stack, is to say we're going to have cryptographic identity at the lowest level possible, so that at this level you're not reliant on some peer-to-peer network. You're just like, this is my individual identity, and I can elect to pass information. I can elect to map up to the next level of heterogeneous, which just means different sort of people interacting together in a fully sufficient capacity, right? So you can elect up into every level. And the same way that Docker sits, I think, on like between the transport layer and the internet layer on the TCP/IP model, you can, if you wanted to, build a decentralized Docker. Like you can take any one of these levels and start building something. You don't actually need to do it all the way from the top, like the same way that Docker is not built on like Node.js. Node.js is just a primitive that allows you to write simple web apps. And Docker is this capability that allows you to deploy virtual machines. You can go down to like the message passing layer of Anoma, and you can build a decentralized Docker. I just so happen to be building a Node.js alternative on top of Anoma. So I hear what you're saying. I think that the way that we ensure that individuals are like safe and respected in this way is that everyone who's building continues to reinforce the notion of personal autonomy. Because that's what we kind of lost when we were doing TCP/IP, was like Google was like, oh my God, we can make a lot of money on advertising if we have everybody's data, so we're just going to take it. So it was like the Google that was the bad actor, and it's because the internet that we had didn't ensure the individual safety. Now we have a new internet stack that ensures individual safety, and it's up to the new versions of Google in the future to add, well, they kind of have to adhere if they want to use the stack. They can't opt out of that, or else the stack doesn't work. But it's up to them to continue to like propagate that message, I guess, further upstream, regardless of where in this stack they build.
Mhm. Mhm. Yeah. I think there's a place in the module where ultimately, like a web, another way to talk about it, it's like it's us, it's like people. And therefore it's every single person taking every single step is kind of like in practice what it requires. So there's always greater balance, and um the scales that you put up earlier, Acacia, I think that that's how I feel about the commentary that John and you just started on, when it's like the arc of technology um is about intent expression being easier and easier, and more things being abstracted away, but that abstraction must be balanced with autonomy, and
Mhm.
um both of those things always have a
Yeah.
mix to be found.
And
um
I think to that last point, Vivek, the way that I think one can best guard against um, abstraction closing down autonomy is by committing to openness and verifiability as far down as you can go. And Vitalik just wrote a post a couple of weeks ago about the importance of openness and verifiability all the way down through the stack. And I think he's said recently that he's really starting to think a lot more about hardware, um, to this point that, like, you know, if I have a black box that I'm using that's really whizzy and cool, but I don't really know what's going on underneath. I can't get in there, inspect the innards, fix them if there's something wrong, modify it for my uses. Then that's interesting, but it's a lot less interesting than if I have that, but I can also open the box and look all the way in.
yeah.
So yeah, yeah.
So, like what you first described is sort of like the experience of building or interacting with like traditional web, in my opinion. Like traditional
Mm,
web is really cool. Like I can use Google to share a document, but I have no ability to access the insides of Google and understand what's going on.
hmm
The whole idea of Anoma building this open source stack is that you actually can see into it. And you can say,
Mm.
oh, this is the mechanism that person is using to send it. And you can even like, depending again, like it's up to the individual developer to enable it. And like, I'm trying to build these standards that make it like literally just a line of code to enable it. But the idea is you can go in as a developer and say, actually, I want to unclick this button. I want to opt out of you sending it via, like, let's say, I don't know, pick a bad like solver and say like, oh, that solver, I don't like them. I don't want to send via them. You guys are going to have to find an alternative route. And
Mm.
the the network almost like flexes to be say, oh, okay, that route's cut off from this person. AKA what that means is at the lower level, you have like a table where it says like this is somebody on my personal block list. So it will find a new route and still send that message. So
Mhm.
the network itself again considers all these things that you're saying. It's up to the developers, and that's also why I've been so hard at work doing what I'm doing to like not leave too much up to assumption, but give people the libraries and ability to write that code super easily.
Mhm. Mhm. If Acacia, we were to go back to your initial slide on client server, where I think that if we took it to its extreme, it's like you have this little laptop that each of us is calling in from. In that image, you have like 6 servers. In practice now, it's like put like 6,000 of them and
Yeah.
like overtake the entire space of the slide is actually where we've gotten, where it's still one little laptop that each of us is dialing in from, but the number of servers in the world, like, over the last 10 years, like how many servers were there 10 years ago versus today? I like don't even, it's got to be like a 10, 100,
Uh,
1,000x.
scary,
And
but
so everything seems kind of like, oh, everything's fine, but it's like, whoa, there's a lot more of those. Now, the question, so that like the question is about the the limitations of counterparty discovery. Because like one thing that that obviously has like just like naturally occurred with servers is like I guess counterparty discovery is almost like not as required, I guess is the way I think about it. Like if I want to make an HTTP request against a Google or against an X.com or even against your personal website, um, I'm making that request and it's getting served to me. Um, and there's no step of like real, like, I guess there's not an intensity around counterparty discovery. But when you brought up the PopCat example, and there's got to be somebody in the network who wants PopCat. The question to me is like, but actually, what if there isn't, right? Because like there's not somebody on the other side of that request. Now, this is the level of technical detail that I really appreciate throughout, where it's like, am I missing something technically about like counterparty discovery obviously is a feature and a bug of peer-to-peer systems. But maybe we can talk about like this issue because I know solvers and incentivizing solvers seems to be a part of outstanding research um, in like a NOMA world.
Yeah, I mean, there's a few things, right? So today the notion is computation happens on servers. The future is that computation happens on the blockchain. Now, the issue today is that blockchain speed is a bottleneck, right? Because we have to replicate state across the network. And so the question with solvers is how do we offset some of the computation that we need to do in the system to other nodes that basically can replace the sort of like server computation that's performed. Because the computation still has to happen, right? Like what we're used to a server performing needs to be performed by somebody. And doing it as a transaction in a mempool that where an individual client is running it and then everybody has, it's just not going to scale. So the idea of a solver is that it can be an agent that acts on someone else's endorsement or behalf. And basically, you can run multiple solvers simultaneously. You don't need to replicate state. You need eventual consistency. And so how you kind of architect the solver also can happen at, let's go back to this one. It can happen at any layer of the NOMA stack. That's the cool part because they've broken down the entire stack. If a solver has the ability to, like, let's say it has a table of all of the cryptographic identities it's in a trusted relationship with, that means that I, as a solver, I have a trusted relationship to an EVM node. I have a trusted relationship to a Bitcoin node. I have a trusted relationship here, here, here. And
Mhm.
I eventually, when a request gets farthest down the stack, and it's kind of like the encapsulation is ripped open and you get a like a little China doll and it's unencapsulated. That little request that says, hey, I want PopCat for this, it can interface between its trusted nodes to get what it wants. So
Mhm.
the solver can work at this lowest level. Um, and like, I want to draw the parallel for like what happens today on your computer. You don't just like send an HTTP request and then it magically goes to the server, right? You have within your network, which is usually your Wi-Fi router, you have a router. Your computer has like a mini router client. But your router basically takes all of the IP addresses that it knows and it tries to say when you make a HTTP request to Google, the router looks and it goes, can I take this DNS name and convert it to the IP address? No. Okay, I'm going to go to a DNS server and I'm going to say, I have this weird name. Can you convert it to an IP? And then it converts the IP and it gives it back to you. And then you send that request over the internet and it routes it through other routers in the network, routes it through exchanges in the network, through all these other layers in the network. It gets it over to an IP address. And what typically happens, you don't just have like one server like this. You have like edge networks and things, but what you mainly have is you have like a load balancer. That is the main IP address. And that load balancer says, okay, I'm going to intake a request and then I'm going to pass it off to one of these other servers. So there's all these different actors that are in this process that are running server primitive architecture. The idea of a solver is that it takes the computing mechanisms and it performs them as an individual, whether it's routing a request forward the same way a router does, whether it's doing like a load balancer where it just sends it, it blasts it like a multicast, whether it's resolving DNS, like the solver kind of takes the place of the server primitive in a sense, in a small sense, right? Because we're decentralizing. There's no central, a load balancer is owned by a central entity. It's owned by Google. If Google is decentralized and if Google is distributed, then you don't have one load balancer you get to. You have an overlay that you want to get to and someone who can fulfill the request. So it's just also just a different notion of thinking because you also have no central owner.
Mm-hmm. Mm-hmm. Yeah. Thank you. That's really helpful.
Okay, awesome.
Any other questions for Acacia? I feel like I could at least ask one more, but I wonder if anyone else has anything. Let's see. I took so many notes. So the last one that I will indulge in is continuing on that thread. You have um, solvers that can take some of this server primitive work over. Um, the question is when you, because you actually haven't brought it up yet, when you think about concordance, which is the work that you're doing, um, given everything that you've shared, given the solver, uh, the layers of the Anoma stack, um, can you maybe drive home this Node.js analogy and what it is that you're hard at work building?
Yeah, fundamentally, the idea of an intent, as we can kind of assume, even just from the surface that we've touched today, is a very labor intensive and like layered sort of topic of research. And the reality for me is that to start, what we're really looking for Web3 is an alternative for the current web. We don't necessarily need to like do all the counterparty discovery today. We don't need to do all of these things today. What we need is the ability to send something that feels like an HTTP request. The ability, really what we want is a developer has the ability to write code that runs in this distributed, decentralized way. And it may not be like super nebulous. They just like, hey, I have some shirts and I want to put them on the decentralized web and I want people to be able to purchase them. I want people to be able to share a link and maybe I can add an affiliate link super easily so that that person who shared it gets a little bit of the revenue. There's pretty simple use cases that we want to be able to enable with
Mm-hmm.
Web3 today. And so the idea of a programmable transaction is we take all this intent research and we just do a subset of just the ability to send one sort of known request in your known system through a network of what we already know is like of nodes. So we know EVM exists, we know Bitcoin exists, we know Solana exists as these like layer ones with their respective layer twos. And we know that some state exists in these segmented places. And so the idea is just with concordance is just that you can write code that feels like you're running a server that allows you to have a fully functional app in this Web3 environment. So we don't worry about like the solver system yet. We just say, I can send a transaction and I know that Ethereum has some of my states, so I'll send it to Ethereum. And that system will actually run my transaction, take the necessary money in and out, and do this like e-commerce exchange, right? So like take away the one shirt like in my inventory minus that number, and then I will have like my manual process of like packaging the shirt and shipping it out.
Okay.
So yeah, our first goal is to just replace the Web 2 experience that developers are used to feeling today with the Web 3 experience that's like super accessible and enables them to do everything they do in Web 2 fully in Web 3.
Mhm.
And then we can get into these once we have, I think about once we've actually shifted everybody into this space, then we can start asking more interesting questions about now we have every single stack, every single layer of the stack considered. We have everybody's data. And what we also have is what I think are like paths, right? Like
Yeah.
people repeatedly do the same thing. And so now we can do some more interesting research. Okay, everyone is always doing these things. What can we enable with that? And then, how do we go down the stack and unravel the stack to enable new things like that? So it's just sort of a landing point for this really broad and nebulous sort of research in a way that is super accessible to developers who want to build apps.
Yeah. It's yeah, super exciting. Conversation with you like this many times during the convo, it just reminds you of like, I don't know, for me, it reminds me of like 1975, like 1982, right? And it's like you're looking at this thing, you're like, wow, look at all of these things that are potentially possible. And then, okay, for now, let's just like do a rebuild. Let's be able to like do a simple website that end to end is trust verifiable. And if we succeed in that goal, it's like the toy plane. It's any piece of early tech that feels like a toy in its first iteration, but you're like, whoa, I cannot believe we got that to happen. So I'm really encouraged by your work. I think that over the next decade, it's going to um, increase in awareness and viability, and it represents in many ways the best of kernel. And so thank you for sharing.
Thank you. I appreciate that feedback. And I love how you kind of took everything I said and made it clean and neat. And yes, so we're allowing people to build websites and reinventing what the website means functionally and what people can enable, and then we can grow from there. But yeah, I love Kernel. It's my favorite corner of the internet, and I'm happy that you gave me some time here to chat.
Yeah, of course. Take care, everybody. We'll see you soon. Fireside next week on internet age institutions and a quieter week leading up to Expo. We'd love for you to sign up within the next 7 days, and we're gonna do our best to get a good group together and share more about who's attending. So take care, everybody. See you soon.